Chapter 27, Suspension Systems, Day 2, Video 4, Tram Bar Measurements. So we can use the same tram bar that we used for our front axle checking toe adjustment and use that to check positioning of the rear axles in relationship to each other and then later on in relationship to the center line of the frame. So here we've got two drive axles here, and on the drive axle it's got the the axle shaft flange that is bolted to the outside of the hub, and then the axle shaft extends into the center differential. Well, on the center of that flange is a small dimple that is perfectly centered in that axle flange, and then our other drive axle is going to be exactly the same way. So if we take this tram bar and measure the points from the center of that dimple from our front axle to the center of the dimple on the rear axle, we can now set that as a measurement as the distance between the center lines of these two axles. We would then take the tram bar to the other side of the truck, to the axles on the other side, and ideally those measurements should line up, right? So that when we put that tram bar in there, it will engage the center of this dimple, and then the other point will engage the center of the front axle. That will let us know if the distance between the axles is the same or consistent side to side. If we find that one side is either narrower or wider than the other side, that will let us know that we've got a suspension issue, that's allowed these axles to come out of alignment with each other. One of the things to note is we have to use a tram bar because the tire, just because of the offset, extends past the end of the axle, and we wouldn't be able to get a tape measure to get an accurate measurement from center line to center line. And likewise, we don't want to measure from rim flange to rim flange. Again, an inconsistent measurement. We've got variations in the manufacture of the wheels and that. We're far better to go to center line to center, or center point to center point of those axles using the drive flange. So we can use, see, that's very practical. What we're doing there is very practical in the field or in the shop. Check to make sure that the distance between the passenger side of the axle center line is the same as our drive axle, or the driver's side axle lines. That will let us know that at least the axles are in alignment with each other, but we don't know about the alignment with the frame. So one of the things we can do is clamp a wide enough straight edge that will extend side to side on the truck across the frame. One of the things that we know about the frame is they are a mirror image. Each side of the frame rail is a mirror image of each other. So that if we find a point here, it looks like we're using a mounting point for one of the cross members here, and now we can lay that straight edge across using that mounting point as a reference, clamp that straight edge down, and we've got a framing square to make sure that we're at the proper angle here, get a consistent, that the straight edge is perpendicular to the frame. So what we can do now is take that tram bar and make a measurement from the edge of the straight edge to the center line of my front axle. We can then transfer that measurement. We should have the measurement A should be the same side to side. I would like to see this measurement to the center line of this axle the same as the other side. That lets me know that that front axle is in alignment with the frame. And then likewise a measurement from our straight edge to the center line of the rear axle, and so length B should be equal side to side. So that would let me know that basically that the axles are in alignment with each other, and now the axles are in alignment with the frame.